All right, when we were doing our sum and difference formula for cosine, I said if there was time, I would put up some videos for how to get to the sine, the plus and minus of the sine, and the tangent. So that's what we're going to do right now. And these ones, we're actually going to start with our already agreed upon cosine formula. And just one other thing that you have to know, and so let's remember that. So let's talk about our cofunction identity for just a second. If you remember, your cofunction identity says that sine of x is equal to cosine of pi over 2 minus x, or you could think about it as cosine, if you like degrees better, of 90 minus x. So if you remember, these are our cofunction identities. I'm actually going to use this idea here. I'm going to say that sine of x plus y has to equal cosine of pi over 2 minus x plus y. So what am I saying here? It's like saying this guy is this one, and it's minus pi over 2. So this whole x plus y is standing in for the x in this particular expression. And the pi over 2, of course, is the same, or the 90, whichever way you like to think about it. So I'm just replacing the x with x plus y because that's the angle that I have over here. So whatever that angle is, I've replaced them both with x plus y, which, of course, in a formula, you can replace them with whatever you want as long as you're replacing them all the same thing. So from here, what are we going to do? Well, I'm actually going to think about it more like this. I'm going to write it as cosine. So let's put a little box around here because he's kind of on the side. I shouldn't have written him probably right in the way, but so pi over 2 minus x minus y. So I'm distributing the negative over these two, and I'm just going to group these two up instead. And why am I doing that? Well, now when I look at it, this becomes my first angle and this becomes my second angle. I'm going to think about this as the u and this as the v in my sum and difference formula. So if you remember our sum and difference formula for cosine, maybe I can just move this down a little. We'll keep this one. Our sum and difference formula for cosine, of course, is cosine u minus v is equal to cosine u cosine v plus sine u sine v. So I'm actually going to use this formula now where this is my u and this is my v. And why did I regroup it? It's because I don't really know what to do with this, but this is something I know what to do with because we just talked about our cofunction identity. So I'll probably be able to use that one. Okay? So I'm going to plug this into my formula. So this I'm going to put in everywhere I see u, and so I'm going to put everywhere I see v. So I'm going to have cosine of pi over 2 minus x times cosine of y plus sine of pi over 2 minus x sine y. Okay? So why did I change it to that? Well, of course, this one, using my cofunction identity, I know that he's actually just sine of x. So this one is sine x. He stays cosine y. And this one right here, we know that he is actually just cosine of x. So that would be plus cosine of x sine y. So from here we can see that sine of x plus y is actually equal to sine x cosine y plus cosine x sine y, just by using my cofunction identity. Pretty clever, huh? So that takes care of my sine one. That was pretty simple. Now my tangent one is actually not too challenging either. We're going to use another identity that we know. And the one that we're going to use is our quotient identity. We're going to say that it is sine x plus y over cosine of x plus y. Right? So what is sine x plus y? That one is sine x cosine y plus sine y cosine x, or you can put them in any order we talked about. It doesn't really matter. And cosine is cosine x cosine y minus cosine x, minus sine, sorry. I always do that. I get carried away. sine y. So sine x, sine y. Okay? Now what am I going to do from here? I'm actually going to do something a little bit kooky, and if you've watched me in class, you've seen this kind of thing before. But if we know where we're trying to get to with this formula, we know that we need this thing to be a 1. For those of you that have already looked at the sum and difference formula for tangent. And so what I'm going to do is I'm actually going to divide this by that. So I'm actually going to multiply the top and the bottom by 1 over cosine x cosine y, and it's the same reason I do that in my identities. I know where I'm trying to get to because I have the benefit of already having seen the formula before. I'm not coming up with it brand new out of my brain, so I have a little bit of an advantage. So I know if I'm trying to get this term to be a 1, I actually know how to do that. I can do it by multiplying by 1 over cosine x cosine y, or in other words, dividing everything by cosine x cosine y. So when I do that, I get sine x cosine y over cosine x cosine y plus sine y cosine x over that same thing. And down here, when I multiply these two things, you're going to obviously see, I wasn't going to write it, but I won't be lazy. I'll write it. We can see it's a 1. And then minus sine x sine y over cosine x cosine y. Okay? Nice. So now, what do we do with this? Let's simplify this up. So hopefully you can see this is going to cancel out. This is going to cancel out. These cancel out. This is a 1. This piece becomes tan x, right? And this piece becomes tan y. Do you see that? And what, of course, is this one? And this one. So we can see here what's going to happen, something wonderful. So I'll write it out just in case that confused you, but hopefully you could see what I was doing. I got sine x over cosine x is the only thing left here, and that's a tan x. The only thing left here is a sine y over cosine y, and of course that's a tan y. This we just said simplifies to 1, and this is sine x over cosine x, and if you can't see it, I'll split them up, times sine y over cosine y. And then, of course, we can just change those all to tangents, which is going to give us our formula. So it's going to be tan x plus tan y. And again, I don't know which way your book writes it or which way you remember it, but it really doesn't matter because it's commutative. And it'll be, this one becomes tan x tan y. And there's your sum and difference formula for tangent also. So that's how we get to those ones from our cosine one, which we showed geometrically.